Hello everybody and welcome to this open web meeting. Today we will talk about how to win the Industry 4.0 revolution in working with best partners and adapting the right business models with the support of DIH². What is the goal of the DIH² initiative? We especially address, as you can see from this slide, three major points in supporting SMEs to get a strong positioning in adapting robotics. In the first point, in targeting the right applications and vertical businesses and bring at the same time added value with robotics. The second point, in targeting and using the best technologies to generate differentiation and competitive positioning. And the third point is about adapting the right business and revenue models. As you know, the world is changing fast and it has a direct and strong impact on manufacturing. So DIH² has received the support of the European Commission to support SMEs to enter into agile production and to develop competitive advantages. We know that it requires specific resources and competencies to enter into the game. And this is the reason why DIH² will also financially support you, not only in finding the right partners, but also funding you with up to 248K for collaboration with among 2 to 3 partners, and for a program that will run for 10 months. As well, from this project, there will be 26 projects that will be supported. So you can see there, you can see the slide here. And now passing to the next. DIH², we will talk about the DIH² open call process. Here you can see the open call process in a glance. The first stage of the open call was closed on October 31st. We are currently in the first stage of the selection and matchmaking process. It started the 1st of November and it is ongoing. And from 3 days, we have launched the second stage of the open call, where you need to create a consortia with 2 to 3 partners with a minimum of 1 end user and 1 technology provider. So, hello everybody, I am Ermira Vodo, Open Innovation Project Manager from Lumorpho. And I am here with Ioan Boha, Innovation Developer at Lumorpho.
Hello everybody.
Hello Ioan. We are very pleased to welcome you to this open web meeting. Take the time to ask your questions on the question box on the right part of your screen. I am seeing that we have already different questions that we will read later. So, what is our goal today? Our goal today in this open web meeting is to support you to prepare phase 2 in DIH². Some of you have already applied in phase 1. Now you have to build your consortium to apply for phase 2 with the right partners addressing your technical needs, and we are here for that. To help you through the process, we have structured the following content. You can have a look now to the agenda. The first part we will introduce is why Agile Production and what are the possible business models. The introduction of potential partners for collaboration. We have today with us 4 speakers, around technologies, Acilin, 3DMEO, and DFD. After that, we will talk about what to do next, and we will conclude with a Q&A session. So please, again, do not hesitate to ask your questions. So to introduce you very fast the speakers, we are here with Damian from Around Technologies. Hello, Damian.
Hello, Mira. Hello, everybody.
After we have Alan from Acilin. Hello, Alan.
Hello.
After we have 3DMEO, we have David and Elvis. Today will be David to present, and Elvis will be your contact point if you want to enter in contact with this company. Hello, David.
Hello, everyone. Hello, Mira.
And finally, we have Dominique from DFD. Dominique actually is not present today, so it will be Ioan that will present DFD. Hello again, Ioan.
Hello again.
Let's start with the 3 major challenges. What are the current challenges that Europe is facing in manufacturing? Here you can see the main points. The first deals with the competition of China and emerging economies like Brazil. As you all know, the issue we are facing in Europe is that we have higher labor costs and strong regulation, which of course is positive, but at global scale it puts us in difficult situation when dealing with the production. The second part is increasing automation. Lots of high volume production is done in Asia for cost reasons, as you know. And for a long time, globalization has been quite an added value. Things are changing, actually. The opportunity to manufacture in Europe is stronger. The reason behind it is because we see more and more automation, which can be very interesting for high volume production, but also for smaller batches. In fact, for smaller batches, we need more adaptability. And as you will see, a solution has emerged to make it happen. So this is really an opportunity for Europe. The third point is smarter customer base. What does it mean? It refers to the smart customer base, which is very important, especially in Europe, as the final customers are very careful and pay a lot of attention to how the goods they are buying are produced. This evolution in the customer mindset is again an opportunity for the production in Europe to produce closer to the customers with lower impact in the environment. So we can consider that the closer, the less CO2 emissions impact. Okay, so in a glance, we can pass to the next slide, AI and disruption opportunities, including Europe. As you can see here, the world is changing and is changing fast, not only in Europe, but as well in Asia. We have emerging technologies like AI bringing real disruption globally. And currently, everybody is speaking, as you know, about artificial intelligence. And artificial intelligence is bringing a lot of different opportunities. This is true for China, for North America, and also for Europe. Access to technology has to be considered as an opportunity for all organizations, and this is what DIH² is focusing on. So to have a very fast look to the rapid change in the manufacturing ecosystem, as you can see here, when mentioning that customers are more and more important to be taken into account, not only to sell, but also to produce. So just to give you an example, you can see this scheme. We can have a look how in this scheme, the rapid change in the manufacturing ecosystem with evolution we have the evolution of the production that is going closer to the customer. The production close to the customer is becoming more and more common, as well as the creation of products by customers. So you can see here the maker of economy. And the maker of economy is a new opportunity for you to assess new ways, new solutions to address your market. Okay, so we saw different examples. We saw some statistics, and this is a definition, as defined by the European Commission. The Agile Production can be described as follows. I will not read everything here, but just for you to have an idea, and later you will receive this presentation as well. I would like now to talk a bit more about the business models. The future of manufacturing is driven by new business models. So what is a business model? You can see in this slide two short definitions, the business model and the revenue model. The business model is described as the way a company generates, delivers, and captures value for itself as well as for its customers. And the revenue model, which is a part of the business model, it describes the structure of how the company generates revenue, and each customer segment can contain one or more revenue streams. So the difference can be illustrated by the individual components of a business model. In essence, we have like four factors that describe business model. Who are the target customers? So the segment relationships. What is the benefit that the company provides to its customers and most important partners in the value chain? The third component is how does the company delivers this benefit? And the fourth, how does the company earns money? And this fourth is exactly the revenue model. In a glance, you can see a few revenue models. Here we have taken two different examples. The anything as a service, the X goes for anything, and here are a few examples like the infrastructure as a service, the platform and software as a service. And regarding the smart factory as a service, we have the machine. Of course, as you know, there are many more, but here is just to have a first idea. And we have spoken about the business models in the previous webinar. So if you wish, please let us know and we will send you the presentation. So the XaaS pay-per-use. This is the pay-per-use is any type of payment structure in which the customers have unlimited access to resources, but only pay for what they use. You can see here three major trends. That is the sharing instead of ownership, personalization, and non-planned obsolescence, and the different benefits. Today, the consumers, the as-a-service model became synonyms of anywhere, real-time, personalized services, and the ongoing value. And the benefits, some of the benefits are reduced entry barriers, increased flexibility, and improved quality of service 24/7. And regarding the smart factory as a service, as you can see here are shown different benefits, and the smart factory as a service is a combination between competencies such as software integration, automation technology, systems engineering, and risk and financial management. How does it work? You actually negotiate the KPIs of the equipment in advance, and there is no purchase of the machine, instead purchase of the subscription, and hence the machine as a service. To be agile is to have the capability to survive and prosper in conditions of unpredictable change by reacting quickly and effectively to changing markets. One of the keys also to survive is to benefit from the best ecosystem. Thus, we are glad to introduce you our speakers that are part of the DIH² ecosystem and that we encourage you to join. Okay, so we have the first speaker with us today is ROMP Technology.
So my company, ROMP Technologies, ROMP stands for Robotics and Mobility, and we are active in the logistics sector. So as many of you are aware, there is, with increasing production and increasing global trade, there is more and more pressure on goods storage and transportation. So every item that we use gets loaded and unloaded at different stages of its life cycle. And this is right now mostly done manually, usually by using forklifts or similar vehicles. So our solution to this problem is to provide autonomous capabilities to the forklifts. So this is an example of a project that we did together with a partner in Hong Kong, where they retrofitted a forklift with sensors and computing power. This was a normal manually operated forklift, and we provided the algorithms that endowed this machine with autonomous navigation capabilities. So using the sensors, the machine could determine accurately its position in the environment, and then using navigation algorithms, it could execute missions such as picking up and placing objects in the environment. What's specific about these applications is that the level of accuracy is very high. So these machines need to be able to position themselves in the environment within less than 5 millimeters to be able to execute pickup and delivery missions. So this technology as itself, like is not new. So vehicles like this are usually known as AGVs, or autonomously guided vehicles in the industry, and they have been around for 20 or 30 years. However, typically they will use some fixed infrastructure to aid the navigation. For instance, either there's going to be some magnetic stripes in the floor that allow the vehicle to follow a path, or there is going to be some infrastructure, some reflective markers in the environment helping the vehicle localize itself. Our technology allows the vehicle to do this without any interventions in the infrastructure, which brings down the setup and maintenance costs. So this is our main competitive advantage. So these are some market trends for the for forklifts in general and for AGVs as a segment of this market. And basically, our idea or our vision is that most of these machines in the near future are going to be autonomous and operate without the need for humans to drive them. So as I said, our differentiation points are advanced navigation algorithms, better resource utilization, and lower setup costs of the logistics facility. And we're currently considering two business models or like two customer segments. One is system integrators who have their own hardware and we just provide the software, or we are also can provide a complete autonomy pack, which can then be sold or leased to end users. And this is our founding team. So we have an academic background. We come from the University of Zagreb from the laboratory of robotics and intelligent control systems. And that's it. I'm the contact person, Damjan Miklic, the CEO of the company.
We are going to change of technology provider, and I'm going to leave the floor to Asril.
I would like to present actually our technology. So we are a company making feeding systems, and the problem actually in automation lines is that very often you get products all together in bulks or parts components that you have to assemble, like here. And the first thing, if you want to assemble the parts with a robot, you need to separate them like this. So you need to have them one by one, very often to give to the manipulator at a given position in the desired orientation and in a given time. So this is actually the process that we call feeding in the industry. Now, the traditional way to solve this problem is it's old technology called bowl feeders that we see on this image here. So the principle of the bowl feeder is that you put all the parts all together into a kind of bowl, and then by vibration you are able to make the parts move on a ramp here until they come here to the end of the bowl, and they are usually mechanically selected. So this technology is an established technology, but unfortunately is dedicated only for one part geometry. If you change slightly the geometry of the parts you want to feed, then you need to design a new bowl. Usually the advantage of this is that you can be very fast, but you don't have the flexibility that is needed today in modern production lines. So what we provide is actually flexible part feeding. So these flexible part feedings, as the name says, can be used for many different kind of components, and it works in our case up to 99% of part geometries. It works also for very delicate parts or parts that cannot be fed using traditional bowl feeders. Contrarily to bowl feeders, when you have a bowl feeder, you need to know the parts before you can design the bowl. So you cannot actually have a joint development of the production line. So you first to have the part, and then you can design the feedings. In our case, it's different. We have a very short delivery time because we can actually already produce line while actually changing just some parameters to be able to feed new parts. So there is no need to customize the system for the parts. So how does it work? Actually, the first thing is that you bring the parts into what we call hopper. After that, the hopper brings a certain number of parts on the surface that we call the plate. We vibrate it very intelligently so that we can separate the parts on this surface. After that, we use a camera to take a picture. With this picture, we analyze the position of the parts, their orientation, and we give this information to a robot that will pick the part at the right position and bring them onto a tray or make the assembly directly. So now we have actually, as a feeding systems, we have a range of different sizes because we need to adapt to the size of the part. And in our case, we can handle parts from 0.1 millimeter, very, very small parts that we have in watch industry, for example, to up to 150 millimeters, so quite big parts for the industry. So our business model is to sell actually the components, so those cells, the feeders, the vision system. We do not sell solution. And today we work actually worldwide through together with 40 distributors in 29 countries. We are headquartered in Switzerland, in the French part of Switzerland, and we have just opened an office in Minneapolis this year to also help our customers in USA to better use our product. So the customer benefits are unmatched production flexibility. We can produce very small batches because we are able to change very quickly from one part to the other by just changing some software parameters. We have the fastest flexible feeding technology on the market. And actually we can manage to work with almost all parts, 99% of the parts. So these are the customer benefit we bring. So I would like to thank you for your attention.
Thank you very much, Alan. This was very interesting. And now we will pass to the next speaker.
Yes, so I'm David Partouche, CEO at 3DMEO. Elvis is our business development manager. I couldn't make it to this event, but you can contact him if you want to get the datasheet of the product, or if you have any question, or you want to discuss in further detail the possibilities. So 3DMEO provides its industrial customers with high-speed and multispectral 3D vision solutions that make it possible to perform short cycle time robotic guidance processes or high-speed quality checks. So our solution comprises both the hardware and the vision software which is ready to be integrated into the manufacturing line, along with robots and PLCs. And the hardware includes a high-performance controller computer, and of course, our 3D multispectral camera, which is our core technology. So our core technology is based on a novel way of performing 3D imaging. Actually, multispectral 3D imaging. This technology was invented in 2014 at CEA, and 3DMEO is the only company worldwide providing high-speed multispectral 3D cameras. So what does this technology do? Here you have an example. We placed a gray sealing joint onto a car metallic part, so the same color, intentionally to make the test difficult. And thanks to the spectral data, we can automatically locate the joint directly onto the part, directly onto the 3D data point. So if you can automatically detect the joint onto the data point, you can perform a quality check. For example, you can check its location onto the part, or its continuity, or its volumetry, for example. So the application of this technology are several. You have several examples here. In terms of quality check or starting, something interesting is the color recognition capability of this solution. And this is even in variable ambient condition, because I will discuss a built-in feature regarding ambient light condition. It can be the monitoring of a color process, painting process, for example, and and also accurate and fast, actually, robotic guidance. And actually, this is a key solution that might be of interest to you and that I will present next. So this solution is a non-board 3D localization solution. As you can see on the picture, the camera is boarded onto the robot along with a gripper if you want to pick up parts, but it can be used for other application, other manufacturing application. Its initial use is fast and precise 3D localization. So a typical application is depalletizing, for example. And it's actually very handy if you have several pallets, say 2 or 3, and you want to deal with them all with only one robot and one vision solution to deal with them all. So the key differentiation of our solution is that it is both fast and precise. Precise means, in our words, 3D localization precision that is below 1 millimeter. And fast is because from the time the robot triggers the camera, it gets the part localization in less than 2 seconds. And actually, most generally, it's 1.5 seconds on most parts. 2 seconds is for very large parts. In addition, I mentioned it, our solution has a built-in ambient light correction. Said differently, during the course of the day or from a season to a season, you will get reliable 3D localization because any variation in the ambient light will be taken care dynamically on each acquisition. And also it features a learning capability. Of course, you can locate the part based on its CAD model, but there is a learning capability that allow you to teach to the robot what the part looks like with its own eye. And this saves a lot of time and allow to introduce new parts very quickly in the process. And finally, to finish, what is the return on investment for the customer? It comes from 2 aspects. First, an increased productivity because this solution is both fast and accurate, which is uncommon, as opposed, for example, as something that would be accurate and slow in localizing parts. And also it's very reliable, so you get less interruption of the manufacturing line comparing to some existing solution. For example, solution using 2D vision and laser distance meter boarded onto the robot. And the second aspect is that the integration on a robot is very quick. First, it's mechanically simple, of course, but also the robot programming is very simplified with our solution. Well, all in all, it takes less than 2 weeks to integrate vision onto a robot on a manufacturing line. So thank you for your attention. I think I'm going to give you the floor back.
Thank you very much, David. And now we pass to the next speaker. We have DFD, Dense Fluid Degreasing, and will be Johan to present it. Johan, the floor is yours.
Okay, so let's start with DFD and finish with this solution today. So we are going to speak about cleaning and high quality green cleaning. So DFD is providing a solution to replace classical cleaning based on water and chemical. So DFD provides a solution without any water and without any chemical product to make the cleaning. So that's really the new things on this technology. It's here. And what I would say about DFD, it's bringing to agile cleaning process in your process. That's DFD. It's going to make your people working on the cleaning step available for new step, for new job. So that's the idea behind DFD. Okay, so some example of use case of this cleaning solution. DFD is specially adapted to clean and decreasing any parts like mechanical parts, even if there is some complex shape, or also really adapted to clean some polymer and fabrics. Here on the slide, you can see some example of what you can clean with the DFD equipment. So you can clean, as I was saying, textile based on polymer. And also you are really adapted to clean mechanical parts and remove any trace of grease contained on the part. So it's really a high quality, super cleaning. That's the idea with DFD. Other kind of use case of DFD equipment is to make surface preparation before assembly. So with DFD, you are able to make some really good cleaning to improve the bonding of multi-material. That will be an idea, an example of use case. Another use case is also for, I would say, medical application. Thanks to DFD technology, you're able to achieve very high quality cleaning and sterilization. So it could be also a use case to use DFD solution. So in few words, if we have to compare DFD, if we have to keep in mind the strengths of DFD, I would say DFD is working without any water. So thanks to this, you don't have any more wastewater to handle. So it's making the process, the cleaning process, more easier. Also, thanks to DFD technology, you don't use any more chemical products. So you don't have to handle any more VOC trouble in your equipment, in your fabric. Also, thanks to the fact that there is no water, you don't have any more to make drying. So that's going to make your process more faster and also with a lower cost. So the OPEX at the end is lower with this kind of equipment. You are going to use less resources in terms of human people. You are going to use less resources as water and energy for drying. So you have a very low OPEX with this kind of equipment. And one strong point also is this, thanks to the fact that there is not any more chemical, you don't have any more trace or residual detergent on the part. So that is what I call super cleaning. You have a very high-end cleaning. So DFD is a reliable and non-polluting alternative to chlorinate petroleum-based and detergent processes. Okay, here on the screen you can see the equipment that we are speaking since the few slides ago. So as you can see, it's a large equipment based on a specific technology designed by DFD called supercritical CO2. So that's why there is no water and no chemical. It's not magic, it's physics. So the value proposition of DFD is the efficiency in increasing your productivity. So you are going to reduce your cleaning time by 5 or 10 times, and especially for the medical device. So you are not anymore working in ATEX constraints thanks to this technology. So I mentioned also the OPEX is very low, so you are going to decrease your operating cost by 2 or 4. And you are going to also increase the quality of your cleaning. Okay. So that's here a short presentation about the DFD. Of course, if you need more information and if you are interested to have more detail about the DFD technology, here on the screen you see the two contact points for this technology, and it will be a pleasure to set a meeting with them.
Thank you very much, Johan. So what to do next? You'll in the next slide, you'll see our links. There are a few useful links. We start with the guide for applicants. You have the link where you can you have different questions, frequently asked questions answered here. You can go and you can download it directly. Regarding the brokerage events, because different attendees here come from the first stage of the open call, and now you are waiting for the brokerage event. So feel free to contact directly your country, DIH² country representative following this link here. And if you have any question, do not hesitate to email us. As I mentioned in the beginning of this open web meeting, the open call has two different stages. The first one was closed, and the second one was launched on the 3rd of December. So right now, you will have to create the consortia with the different and to find strategic partners to do that. The deadline for the second stage is the 27th of February. A very fast look to the partners. We are 37 partners. You can find all the partners from different countries here. And you have here my contact details. For any question, you can reach me by phone or by email, and I will be very glad to answer you. And right now we have the Q&A. Questions and answers. We start with a few questions. Are there different web meetings for different brokerage events? So I wanted to clarify here that the open web meetings like this one are complementary to the brokerage events. We will have 3 more. The next one is the 12th of December and the 18th of December and the 15th of January. Please feel free to register and to attend all of them because they are all different. We will introduce you different technology providers that you can create a partnership with. And we will send you, of course, the recorded version.
Mia, we have a question for 3D Maybe we can go to this one. I don't know if it's possible to answer, but we have a question from Greg to David about what sensors do you use for 3D location? So maybe Greg has an interest for collaboration with 3D I don't know if David, you can answer to this question now, or if you prefer answering later on.
Yes, actually, we use a new technology. It was invented in 2014, as I mentioned. So we fully built the sensor. The sensors comprises 2 systems. The first one is a projector, what we call a spectrally coded light projector. Said differently, we encode binary data directly on the spectrum of light in this technology. And the second system is a camera, actually a high-speed multispectral 2D camera that we use to decode the information. So all in all, this new technology allows us to get a 3D image, a color image, and a multispectral image all at the same time. So we fully manufacture the hardware.
Perfect. I hope you answered the question, but in any case, I think we can put you in contact, both of you. Actually, we have same kind of question, but for RAM technologies. What kind of sensors do you use in the autonomous approach? And do you use machine learning?
Yes, so thank you for the question. So in our current prototypes that we have tested, we're using LiDAR sensors, and we're not using machine learning with that. We're using 2D LiDAR sensors and different variations of SLAM algorithms. We have some prototypes under development where we're using depth cameras, but this is still under development, so we haven't tested this yet or anything.
Okay, good. We have a question for Assyriel now. What is your differentiation compared to Flex Factory any feeder?
So basically what we have is a platform that can move in the parts in any direction. So we call that 3D vibrating system. And when you vibrate, you can actually move the part left, right, and actually then flip them to make an amplitude so that they can change their orientation. So Flex Factory, what they have only one motion. They can only move the part in one direction and not in three, the same as we can do. So this is the main differentiation. And what it means is when you have, for example, parts that with vibration comes on the side of the feeder, with Flex Factory, you cannot bring them to the middle again. With our system, we can actually move freely and bring the parts back to the middle. So this is main differentiation.
Perfect. Thank you very much. We have a new question also for 3D Meo. What is the spectral range you are using? Can you answer that?
Yes, absolutely. It's in the visible range. It's between 470 nanometer, 470 nanometer, and 600 and let's see. No, sorry. 470 nanometer until 630 nanometer.
Okay. And are you using single image or stitching multiple images?
Oh, it's you can consider it's a flash camera. It takes less than a few hundreds of milliseconds to get the image, and 300 more to calculate the 3D image. So in 600 milliseconds, you get not only the scan but also the 3D reconstruction and multispectral image.
So it's not as complex as it could look like, right? It's smart, but designed for industry, correct?
Yes, it is designed not only for industry but also to be boarded on robots. There is no moving part in there, and it's a kind of a robust design so that it can handle to be on a robot all day long.
So this is a question coming from Preben. I see you have a lot of questions for 3D Meo, so I guess the best will be to put you in contact. Could be quite interesting. Mira, do you see additional questions right now?
Yes, for Asavin, what are the economic advantages of the flexible feeding solution compared to traditional feeding?
So thank you for the question. So actually, as I mentioned in my presentation, the classical traditional feeding solution is actually to use the bowl feeders, and the bowl feeders are for only one kind of part. So the flexible feeding has the advantage of being able to handle a huge variation in products because of its high flexibility. And we can also work on very small production batches because it's very quick to change from one product to the other one. So this makes actually the whole system, so the return on investment when you have to have a very huge variation in the product, very efficient. You get very good return on investment with this solution.
Thank you very much. And for 3D Meo, what kind of feedback do you get from your customers?
What kind of feedback? Actually, in one of the slides, there was a feedback from a car manufacturer, what they actually like in this solution is that it's fast to integrate, it's simple to operate. Of course, the main point, it's fast and accurate, of course. Something that we did not expect, as our solution is very reliable, they have an increase in productivity compared to their the current vision solutions that they board onto their robot, and this increase in productivity is due to less interruption of their production lines.
Okay, thank you very much.
I have a question, Mira, for RAM technology. Can your solution be applied to any legacy forklift?
So in principle, yes, but it can be the complexity, the effort involved might differ depending on the forklift. However, so far we have done it with 2 different forklifts from different manufacturers, and there were not any major issues because most forklifts, so the biggest issue is connecting to the drives of the forklift to be able to control the motion. And as far as we know, most forklifts use drives from a company called Curtis, which are on the CAN bus. So as long as we can connect to the CAN bus, we can basically control most forklift types. But again, like for a specific type, we would have to estimate the amount of effort.
Good, thank you. We have a question from Christoph asking if a manufacturing company in the wood sector can be a beneficiary of DIH². Absolutely. The goal of DIH² is really to support any manufacturing company in a lot of different vertical business or application field to benefit from robotic solution to further develop your business. So of course you can totally apply. I see you have a lot of questions regarding technologies and consortia, etc. We will send you the right information, and then I guess it could be good to have a short discussion with you, a phone call with you.
Thank you.
I think we have some more questions. Just one question for 3D. What is your field of view, or rather maximal distance, and do you require specific lighting conditions?
Okay, so we can build three types of system. One for close-up range, 350, about 300 millimeter from the camera. The second one about 500 millimeter from the camera, and the third one about 900 millimeter from the camera. The most common system that people use is the middle range, because actually you're boarded onto a robot arm. So not only you can move around, but you can extend your field of view. Just to complete this, because this is unusual, if your part is small, you can locate it with your field of view, with your camera field of view. But even if your part is big, really bigger than the field of view, since the solution is very accurate, and this is what they do in the car manufacturing industry, they can locate the part from a corner, for example, just a bit of the part, and this precision is generally enough to locate the big thing actually. So by the fact the solution is boarded onto a robot arm, it gives a lot of flexibility in terms of field of view or part size. Just to complete, for an example, not only you can locate your part onto your pallets, but when a new pallets arrive, you can locate your pallets just looking at one edge of the pallet, and you locate it precisely, so you can go and look for your parts.
Good. Okay, last question for Cyril. What is the price difference between your product compared to a traditional ball feeder?
So it's clear. So it depends actually on the application, because a ball feeder can be very complex depending on the parts. And if the ball feeder is actually needs to feed very complex parts, it can be very expensive, much more expensive than our solution. Basically, if you take really basic components, it's clear that our solution is a little bit more expensive, because you need the vibration system plus a camera and plus a robot. But the robot usually is already used for the assembly. So if you compare the price, you need to compare vision and the vibration system compared to a ball feeder. And in this case, we are prices that are very similar, because in our case, you don't need to take into account the engineering to design the ball for the part, because you can just, when you get the parts, just program it very quickly using or man-machine interface. So basically, the answer to that is it depends a lot on the parts you have to do, but we are almost at the same range of price.
Okay, good. Just to make it clear also, those technologies and those solutions have been developed by all the companies we have met today. They will be happy to interact with you to define how you can build consortium all together to apply for DIH², to further support the adoption of robotics, for agile production in a lot of different fields in Europe, with the goal to support you to have a strong leadership, to have a strong advantage, competitive advantage, and to grow. So we hope this webinar has been useful for you. All those technologies are very cutting-edge technologies available for commercial purpose. So it's a good opportunity to go fast and get access to the right solution for you.
Thank you very much, everybody, for following this webinar. I remind you that the next one is the 12th of December, next week. If you haven't registered yet, please do so, because it will be different from this one and we will have new solutions. I would like to remind you that the DIH² initiative is supported, is an action supported by the European Commission. Thank you very much. Have a nice day.